Okay, so we're trying to understand what it is that's true, because if we're not grounded in the truth and what's actually going on in the nature of reality, then we don't really have any power to act in a way that's going to move us towards what we need. And as a healthy organism, we want to move towards what we need. We want to create not only what we need, but what everybody around me needs. What's the environment need in such a way that it nurtures me and everyone else? Okay? We have lots of different ways of making sense of things. We have lots of different cognitive maps. Some of them work better than others for a particular situation. But there's another quality of maps beyond whether it's current and whether its scope is right and that kind of things that we talked about in just the previous video. And that is the question of how much complexity does this map take into account? Does it take into account enough of what's actually going on that it really fits? And part of what we're discovering in the world right now is that everything's incredibly complex and there's great diversity. And so we have to have a way of thinking about things that actually allows us to take that in. Now, Albert Einstein at one point cautioned us that whenever we're trying to solve a problem, we should pick the simplest map possible, but no simpler. Part of what he was saying there was that you can think of a map, you can think of a way of solving the problem in such a way that's simple, but it's so simple that it doesn't actually solve the problem. He also said, and this is one of my favorite quotes from him, is you can't solve a problem with the level of thinking that causes the problem. Sometimes the way that we're thinking about the problem leads us to act in such a way that we create the problem. And I can give you lots of examples of that. So we need to be able to understand that our maps have different levels of complexity in how we understand them. And so I want to suggest to you kind of 4 different categories of maps. They're not really this distinct, but it helps to think of them this way in order to see what's going on. They're simple, complicated, complex, and chaotic. All right, this video is going to be a little longer than some of them, but I think this is a story worth telling because it's sort of like how I really got complexity. I was part of a training seminar. This was going on. It was in a beautiful setting up on an island off the coast of Vancouver, and there were about 30 of us. Imagine yourself in this room, big windows, can see the outdoors, and we're gathered around there, about 30 of us sitting in a circle. And the leaders of this training conference gave us a simple task. And the simple task is where you're sitting, just pick any 2 people in the room and don't let them know who they are. Just kind of pick any 2 people. That's simple, I can do that. All right, now, slightly more complicated. I want you to imagine the line that is the line that's made up of all of the points that are equidistant between those 2 people within the circle. Okay, so all of the points that are equidistant between them. There are a couple of ways to solve this. One is you can pick any 2 points that are equidistant between them and draw a line between that. So that's the line. Or you can draw a line between them, construct a perpendicular, and that perpendicular is that same 2 different ways of creating the same structure in our heads, to be able to visualize what is that line. Okay, that's complicated. All right, now the third step is now go and stand anywhere on that line. You've constructed in your head this line. Now go stand on that line. And so we all get up and we move to a place that's on the line. What do you suppose happens? Chaos, right? Because what's happening is the 2 people that I picked, they're moving because they're moving to the line that they've constructed. And so as we're each moving, we're trying to stay equidistant between these 2 people, and they're moving because they're trying to, and the whole thing just keeps moving. And this is a good example of a complex system, because in a complex system, you have multiple interdependent variables. That is to say that when this changes, it changes that, which changes these other things. And most of the systems of which we are a part are like that. If you're going to try to design anything, you know, even getting the family to agree on where you want to go on vacation. Well, when is this going to be, and what's open, and what's it? You know, it's like all of these different variables that are going to impact how it is that this system is going to function. So simple is, I know how to open a door. Right? Simple's great because you look at the door and you can see where are the hinges. Am I going to push? Am I going to pull? Am I going to be left hand, my right hand? How am I going to do this? There is a best way to do that. Complicated is a series of simple things. Baking a cake is complicated. You have to do all of these different steps, and you have to do them in the right order with a sufficient degree of competency. But if you do that, if you follow the recipe baking a cake, you're going to get a cake if you do it well enough. Complex, there is no best option. There may be in this moment, this is better than that, but things shift, or it's different for different parts of the system. And so it's continually moving. So the global response to the pandemic is a response to a complex system. And it is just on the edge of chaotic because we don't know what it is that's going to happen when we do this. If we wear masks, how much distance do we have, and how do we go back to school? How are we going to deal with this? Is dealing with a complex system. And when we can't really have an adequate map for understanding it, the result is chaos. Now, the good news is that the chaos is not as chaotic as we imagine it to be. There's a whole theory of chaos, but it's a good thing we have high-powered computers, because otherwise we wouldn't be able to get we wouldn't have any understanding of chaos. A hurricane is chaotic. And anytime you see a hurricane approaching the coast of the US, you're going to see on the weather maps, there are going to be a dozen different lines that different models are saying this is how it's going to go. And so it's probably going to be pretty close to the middle of all of those guesses. But we can't say for sure because reality is more chaotic than our most complex maps. So what we want to be able to do is use a map that takes into account the complexity and the diversity of reality, which we can still get our heads around enough that it's actually a useful map, that we can actually make sense of things. So at every step, we want to be growing in our capacity to understand complexity. This is a huge part of wisdom, is to be able to see the complexity that exists in the world. And it's not just either this or that. It's not just either left or right, up or down, Democrat, Republican. It's far more complex than that. And the more we can use those complex maps, the more we can respond meaningfully to the reality of our lives in such a way that we are speaking a helpful truth.